Hello, and welcome to Mastering Python Section 2, Graphical Interfaces, Event-Driven Programming, and Reactive Programming. In this section, we will learn about the current state of the art when it comes to creating user interfaces, and we will look at non-user interface applications of the same concepts. To get there, we're going to take a look at the Kivy user interface framework and its related Kivy layout language. Then we're going to see how to respond to user action events such as clicking or tapping. Next, we'll extend those ideas into responding to changes in internal program state as well. After that, we're going to take that idea even further into full reactive programming with the ReactiveX framework. Finally, we're going to create the user interface for our ORE game. Now it's time to get into the meat of the course, starting with user interfaces in the Kivy user interface framework specifically. That will lead us into a discussion of reactive programming and the ReactiveX framework as well. In this video, we're first going to take a high-level look at what Kivy is and what it does. After that, we're going to walk through the source code of a minimal Kivy program. Then we're going to learn about the Kivy language and use it to make our minimal program even smaller, while at the same time separating our program's visual design from the code that implements the behavior. Finally, we're going to take a deeper look at how Kivy works and what we can do with it. Kivy is a user interface framework for Python programs. Able to work on a very wide range of platforms such as Windows, OS X, and Linux, they've worked out how to package Python programs for Android and iOS. Which means that with Python and Kivy, we can write a single app that runs on pretty much any phone, tablet, or computer. That's awesome. The current trend in user interfaces is away from collections of generically styled user interface elements, and toward having a customized look and feel for each program. Kivy embraces that trend, providing us with the functionality of many common user interface elements such as buttons and text inputs, but provides only a very basic look and feel for them, assuming that we're going to be the ones who decide what they actually look like. Kivy embraces that trend, providing us with the functionality of many common user interface elements, such as buttons and text inputs, but provides only a very basic look and feel for them, assuming that we're going to be the ones who decide what they actually look like. Kivy is also designed to support touch interfaces from the ground up, another feature which makes it very nice for mobile apps, without impacting its ability to handle classic mouse and keyboard interfaces. A minimal Kivy application requires only a few lines of code, which we're going to take a look at now. The very first line imports the Kivy configuration, which we're doing here because we want to adjust some aspects of that configuration from within our own code. A few lines further down, we call config.set to tell Kivy what we want our application window's initial width and height to be. After importing the config, we proceed to import box layout and button elements, which we will use to construct our simple user interface. Finally, we import Kivy's app class, which encapsulates most of the complexity of running a graphical user interface. After setting our config options, we create a subclass of app that contains only a single method called build. The build method's job is to construct the user interface, which we do here by creating a box layout object, adding 2 buttons to it, and returning it. Finally, we have the if double_name equals double_main boilerplate, and inside that block we create an instance of our app class and call its run method, which will loop until the user interface quits the program. And here we have the program in operation. In one sense it doesn't do much, but on the other hand, we're displaying a user interface in 14 lines of code. We can click on the buttons and they visibly respond, even though our own code doesn't do anything with those actions yet. There wasn't really anything in that last program that didn't do something useful. So what do we have here? It looks quite a lot like a program that doesn't do anything at all. It's not, but we can't see all of it yet. Here we have a .kv file, which contains the information that is no longer represented in our Python code. When we instantiated our application class, it automatically goes looking for a kv file with the same name as the class, except all in lowercase and without the word app at the end. If it finds one, it loads it and uses it to do what our build method did in the last example. In fact, this kv file represents exactly the same information as what was removed from our Python code. The idea here is a separation of concerns. Having what a program looks like be only loosely coupled to what it actually does makes sense, because it gives us 2 distinct parts of the program that people can work on in parallel, according to their own particular talents. Even for single-person projects, it can be useful to keep the pieces separate, so we can more easily change things without creating accidental problems for other parts of the program. Given that we're going to be storing and editing this information separately, it makes sense to use a special purpose language like Kivy for it. That way, we can cut out the repetitious code that is needed for building the same structure in a general purpose language like Python. Here's an expanded Kivy file, which demonstrates more of the syntax of the Kivy language. Let's take a look at it line by line. The very first line tells the system that we're going to be providing information about a box layout. It is not a generic rule. We are telling Kivy to create one box layout using the following information. That box layout instance will become the root element of our program's user interface, just as if we'd returned it from the app's build method. A window can have only one root element, and so our Kivy file can only contain one top-level instantiation of a widget. The next two lines provide the values for two of the box layout class's properties, which we provided as keyword arguments when we built the user interface entirely in Python. The capitalization matters. The language is case sensitive, so using letters of the wrong case would prevent the property from being recognized. But more than that, capitalization of the first letter is how the Kivy language differentiates between type names, which start with a capital, and property names, which start with lowercase. Since it has to handle those two things in very different ways, we need to follow the convention. The indentation of the lines also matters. Being indented one level indicates that these lines are part of the box layout object's data. Further levels of indentation, later in the file, indicate additional layers of nesting. Next we have a line indicating that within our box layout, we want to create a button. Kivy knows to create something rather than assign a property value, because the word button begins with a capital letter. This new button, in turn, has its text property set to the word hello. After that, we're creating another new widget as a child of the box layout, but this one is supposed to be an instance of a type called FunnyButton. That's not a standard Kivy widget type, but it doesn't have to be as long as we define it ourselves. We can do that either in Python by subclassing a Kivy widget class, or in the Kivy file. Like the previous button, the FunnyButton has a value assigned to its text property. Now we come to the part where we tell Kivy what FunnyButton means. First, notice that we're no longer indented, and so the information we're providing is no longer directly related to the box layout instance. The angle brackets around the name are the next thing to notice. They mean that this section of the Kivy file does not create a widget instance like the previous section did, but instead establishes the default values for every instance of the FunnyButton type, no matter where it is used. Finally, the @ symbol with the word button after it means that the FunnyButton type is derived from the button type, and so we don't need any additional Python code to define how it works. The next subsection is an assignment to a property called canvas.after. There are three such properties that all widgets have: canvas.before, canvas, and canvas.after, for issuing drawing instructions before, during, and after the main rendering process, respectively. These properties allow us to exert a great deal of control over the appearance of a widget, entirely from within the Kivy file, because they let us specify drawing operations that should be performed while the widget is being rendered on the screen. These operations can be simple, such as the color selection and ellipse rendering that are used here, or much more complex, involving matrix manipulation, stencils, and more. The details are all available in Kivy's documentation for the kivy.graphics package on kivy.org. In this particular instance, we're drawing a green ellipse at the end of the process of rendering a FunnyButton, like you do. Anywhere we create a FunnyButton in our Kivy file, we'll see a normal button with a green ellipse over top of it. We'll see more of the canvas and drawing instructions in the last video of this section, along with more of Kivy in general, when we create our user interface for our board game. So, now we have a pretty good idea about how Kivy and Kivy are structured, and what can be done with them in terms of displaying a user interface.